Hello and thanks for watching. This video is going to review distribution. This is a property that many students are already familiar with. The learning goal is to introduce the distributive property, why we need it, and how it's used. And that comes from the learning target. I can simplify expressions and equations using properties like terms and factoring, the emphasis on the distributive property. Okay, so the first question we need to address is why can we multiply unlike terms together, but we can't combine unlike terms. And this comes from your previous levels, and this comes from combining like terms. So if you look at this example here on the left, in previous levels we've talked about how 3r plus 6m are unlike terms, and we cannot combine them to become 3r6m or 9rm or whatever. None of these are true. This is as simplified as this expression gets. However, when we multiply unlike terms, for example 3r, and the term or the constant 4, when we're multiplying them, we can actually multiply those numbers together. And that is not the same as combining. And so I get a lot of students that say, Mr. Stewart, you can't do this because you said we can't combine like terms. But actually we can. See, what I have here is literally 3 times r times 4. And the commutative property states that I can multiply in any order I want. So I don't know what r is, but that doesn't matter because I'm still just multiplying it to 4 and 3. But I can I can multiply 4 and 3 together to get 12. And then I write r next to it, and that literally means 12 times r. This is why this works. See, we can multiply unlike terms all we want, and that's important to understand for distribution. So, we'll go through some examples first. Here on the left side is an example of an expression that you might have to simplify. Now, this expression can be simplified by combining the like terms inside of the parentheses, which we can do now. See, -8 plus 3, that would be -5. And then I can bring down my -10, bring down my parentheses, and by -2. And then I can simplify further. -5 and -10 equals -15. Bring down my parentheses and my -2. And then I have a -2 times a -15, and that equals a positive 30. And that's great. This is a really great and easy way to simplify this expression by doing the things inside the parentheses. What I'm going to demonstrate for you is the same process, the same expression here on the right while using distribution instead. I can, and you'll notice this, take a little bit more challenging route and use distribution here instead. Remember, distribution is when a number is outside of parentheses. And whether it's a group of numbers in the parenthesis or a single number, that distribution literally means that we are timesing, we are multiplying that number to any of the numbers, all of the numbers inside. And this is an example. If I just said 2 multiplied by 3 as an example up here, this is just -2 times 3. This is why we use multiplication. That is timesing, multiplication. Whoops, -2 times 3. That's important to understand. This is multiplication. Okay, so anyway, I can show this distribution using multiplication here. So -2 times a -8 is a positive 16. -2 times a positive 3 is a -6, and then -2 times a -10 is a positive 20. And as I combine these, this becomes, let's see, 16 minus 6 is 10. 10 plus 20, if I bring this down, equals 30. So you notice how I get the same solution here, getting the same answer, but I'm taking different routes to get there. On the method on the right I used distribution, on the method on the left I used just simplifying in the parentheses. Now here's the important part. When you have variables and constants within a group of parentheses, and then I ask you to simplify, I can no longer do so by simplifying like terms within the parentheses. In other words, 8x plus 3 minus 10y can't be simplified. And so I just can't simplify by combining like terms within the parentheses. So my only method is to use distribution, and this is why. This is an example of why we would want to use distribution and exactly where we'd want to use distribution. So I can simplify this expression by using distribution. 2 times 8x becomes 16x. 2 times positive 3 becomes positive 6. And finally, 2 times negative 10 becomes negative 20y. Now I've gone through these examples simply to show you why we use distribution and how distribution works. It's now your turn to start practicing this. Okay, I will show you a review and then you will try one on your own. This is just with numbers so far, so we'll just practice this. 2 times 4 is 8. 2 times 5 is 10. So notice I put a positive 8 and a positive 10 down there. Don't forget, sometimes you will have extra numbers outside of the parentheses. Please do not try to multiply that number to the number outside of the parentheses. Distribution is only for the number inside the parentheses. So I would just bring down my positive 1. Then I can combine like terms. 8 plus 10 is 18, plus 1 is going to be 19. It's your turn. Okay, so you distributed 3 to the 5 and then 3 to the 6. You'd get 15 plus 18 here. You'd add 2 to that, and you should get 35. Let's move on to the next question. All right. With negatives, you have to watch out for this. This 2 is going to be distributed to a negative 4, and this 2 is also going to be distributed to a negative 5. And so you have to remember your multiplication facts. A positive times a negative will be a negative. So 2 times 4 is 8, and I should get a negative 8 here. A positive times a negative here will also give me a negative. So 2 times negative 5 would be negative 10. And then I would bring down my plus 1. Negative 8 plus negative 10, or negative 8 minus 10, I should say, is negative 18. If I'm adding 1 to that, I'm going to get a negative 17. If you need help with this part of it, you should probably go back and review levels 3 and 4, how to add and subtract integers. Time for you to try it. Okay, so you're distributing a positive times a negative is a negative 15. A positive times a negative is a negative 18. And then you're going to add 2 to this on the outside here. Negative 15 and negative 18 should be, let's see, negative 31, 32, 33. Plus 2, that's going to bring me back to negative 31. Sometimes you'll have a negative outside of the parentheses, and you will need to keep a close eye on that negative. A lot of students will make a mistake by distributing a positive 2 and a positive 2 and ignoring this negative here. Well, we must remember this is a negative times a positive. So a negative 2 times a positive 4 should be a negative 8. And a negative 2 times a Negative 5 should be a positive 10. A negative times a negative is a positive. I could then bring down my plus 1 out here. Negative 8 plus 10 is 2. Add 1 to that, and I get 3. Your turn to try it. Okay, so a negative 3 times a negative 5 is a positive 15. A negative 3 times a positive 6 is a negative 18. And then I can bring my 2 down as well. So 15 minus 18 should be negative 3. And I bring down my plus 2. A negative 3 plus 2 is a negative 1. So there you go. Okay, this needs to be addressed. A lot of times students will ignore completely a single negative outside parentheses, but this is very important to understand. If there is a negative outside the parentheses, you should imagine, in fact you don't have to imagine, it's there, we just don't usually write it. But you need to understand that really this is a negative 1 outside of that parenthesis. And so students say, well, so what? Who cares? It's just a 1. It's not going to change anything. Well, in fact, it does. What is a negative 1 times a positive 4? Negative times a positive is a negative. And then what's a negative 1 times a negative 5? Well, a negative times a negative is a positive. So you notice how this negative 1 literally made everything inside of the parentheses an opposite. Notice how I can't combine this 1 until the multiplication happens. Because of order of operations, multiplication comes before addition. So I'll bring down my 1 here. Negative 4 plus 5, that's a 1. And then I'll bring down my 1 here, and that's 2. Go ahead and try this now. Okay, so you're thinking about this as a negative 1 that's going to be distributed into the 5 minus 6, and then later you're going to add this 2 to it. Negative 1 times 5 is a negative 5. Negative 1 times negative 6 is a positive 6. Yep, that's right. A negative 1 multiplied by anything will just make that number its opposite. I will then add 2 off to the side. Negative 5 plus 6 is 1. And I'm going to bring down my plus 2 here, and this becomes 3. And that's how you get 3 as your answer. Now we can start distributing with variables, now that you've reviewed distribution enough. And so here we go. With variables, remember, we talked about how you cannot combine unlike terms. So you can't do that. You can't do that. But you can multiply unlike terms. So we're going to do that. We're going to do that to simplify this expression. And you'll see how this simplifies. So you first think, okay, what's 2 times 4x? Well, I've got 2 times 4 times x. 2 times 4 is 8, times x is just, well, there's 8x. Then I do 2 times 5. 2 times 5 is 10. And then I bring down my plus 1 on the outside there. Now, I can simplify this expression by combining the constants. 10 plus 1 is 11. I cannot simplify further because 8x cannot be combined with 11. So this is my simplified expression. Okay. So we're going to remember that we need to simplify by distributing and then combining like terms afterward. So this is a continuation of what you've already learned. Go ahead and try it. Okay, so you got 3 times 5x. That's like saying 3 times 5 times x, and that's going to be 15 times x, or just 15x. Then you have 3 times 6. Well, 3 times 6 is 18. Then you bring down your 2. Notice how the 15x can't be combined with the 18 or the 2 because 15x has a variable attached to it, but the constants can be combined. 18 plus 2 is 20, and then I have 15x. Left here. Okay, sometimes you'll be required to distribute with variables. So you have to watch this carefully. 2x times 4x. This is like saying 2 times 4 times x times x. Okay? And then this will be 2x times 5. So this will be kind of like saying 2 times 5 times x. And then I can just bring down my plus 1 out here. So this looks a little lengthy, but the reason I'm doing this is to show you what's happening here. 2 times 4 is 8, so let's go back to the left side. 2 times 4 is 8. And what's the way that we write x times an x? Well, x times x is just x to the second power. That second power means x times itself 2 times. Then I can bring down 2 times 5 times x. Well, 2 times 5 is just 10. So, and then I can bring down my x, and then I can bring down this plus 1. At this point, there is no simplification. All of these terms are unlike. Some people may look at the 8x squared and the 10x and think, they both have x's. You should be able to combine those. But remember, that can't work. That doesn't work because the variables and the powers need to match. And this would be to the power of 1. So that doesn't work. All right. Three times 3x times 5x should be 15x to the second power. 3 times negative 6 should be negative 18x. And then I can add 2 to that. This is the simplified expression. Okay, this is the most missed question, so pay attention here, and you should do just fine. If you pay attention, you'll be all right. Okay. All right. The reason why something like this is really difficult for kids is because of the negative here. Okay, and this negative, makes it a little bit tricky for kids. So you'll be asked to simplify this expression. And a lot of kids will want to start adding numbers together before they can multiply. And remember, order of operations says we have to multiply before we can add. So the first step would be to distribute. 3 times r is 3r. 3 times 5 is 15. So I'm going to write that down. Now, this is where kids miss. They will ignore this subtraction sign. They will multiply the 5 as a positive into this, and then they'll maybe bring down the negative here and put 5r, and then they'll maybe put like negative 20 here. However, this is where they're wrong. You see, because this negative is part of this 5 out here, we would actually have to include that negative to be distributed to everything inside of the parentheses. If, however, you wrote it like this, you only distributed the negative to the to the r, and you did not distribute that to the 20. So here's how we fix this. When you have a negative outside of a parenthesis attached to that constant, you have to think of this as a negative 5. Have to. You absolutely have to. So this is a negative 5 that's going to be distributed to the r. Negative 5 times r is negative 5r. Then this is a negative 5 being distributed to the negative 4. Negative 5 times negative 4 is a positive 20, because a negative times a negative is a positive. Now you can see how we can combine like terms. So the r's are like terms, so I can do 3r minus 5r. Notice how this minus comes down with it. If you're struggling with combining like terms, you should go back and watch the video tutorial on combining like terms. And notice now how the 15 is a constant and so is the 20. So we've got 15 plus 20 here. Now I can combine. Negative 3r minus 5r is negative 2r. And 15 plus 20 is 35. This is my simplified expression from here to here. Much easier to work with. I hope this is helpful.